Okay, so good evening, everyone. Um, Today, as a part of as a part of the tutorial session, in the week three, we'll be looking at the sample problems on value engineering and quality function deployment. So, value engineering, as we all know, it's a systematic method of improving the value of a product that the project produces, and we'll be looking at the problems and the concepts that how it actually produces that. Then the quality function deployment effectively will define customer requirements, and in this particular segment, we try to effectively define particular customer requirements and convert them into detailed engineering requirements and the processes that we need to do. So, with that, let us start with the first question that we have today. The proper sequence of stages in value engineering job plan is. So, it's orientation, then information, then functional analysis, and then creative alternatives. So, the explanation is the orientation basically we would like to identify specific problems to address and serves to determine the scope of the project. So this phase is the first to determine the scope of the project, and then we would like to determine and collect the information, and we would like to know about the project from whatever research is readily available. And then with the information collected so far, we would like to identify the project's high cost elements, the basically the bottlenecks. And then in the creative analysis part, we would like to develop viable alternatives to the way of the project is currently designed. So if there are any other alternatives, we would also like to consider that. So if you, so this is the generic procedure of functional value engineering process. So let's come on to the second question, which is one of the major focus area of the value engineering is cost reduction without compromising on the product quality and its functions. Yes, so it is true. So it is quite self-explanatory. So we would like our um, process to reduce the cost, the overall cost that we have, without compromising the quality and the utility it is able to provide us. So then coming on to the third question, that is functional analysis is the third step of the value engineering job plan. The statement is, yeah, yeah, as we just discussed, first we try to orient along the problem, collect information about it, then we do analysis on the collected information, and then we search for alternatives for the same process. Then coming on to fast, that what does fast stand for? So we have four options here. Yes, that is correct. So fast is basically functional analysis system technique, and I would like you guys not to get confused with the terminologies or the abbreviations here. So this is a generic diagram. On the right we can see a generic diagram of how does a fast diagram look like. So this is an example where we are looking for how to catch a mice. So the objective is to eliminate mice, and so this is how this we from this axis we basically define the process as how we would like to proceed with the process, and on the from the right to the left we would like to answer why we it, we are actually doing this process to um, um, get our the major motive, that is the eliminate mice. And the second question is also related to the fast diagram. The following type of logic is are used for identification of various functions of product in fast diagram. Yes, so as you can see in the previous example also and in this example also, the block diagrams that we generally create, which is basically once we um, we will do only let's say swing the striker only when the trigger is uh, um, activated. So that is like an AND operation which is requiring one all to be one at a particular point to actually go to the second state. And we also come up across certain scenarios where we deploy our OR logic where let's say if we are able to attract the mouse, not in this example I can define the OR logic here properly, but you can guess, like there will be process blocks where we will be looking for, if this doesn't work then we would go for the other guy, or type of logic where um, either one of the conditions, if even if one of the conditions is true, we would like to go for the next block. So then coming on to the next question, which of the following is are not to be considered as an outcome of successful implementation of value engineering study? Yep. It is again self-explanatory. So we would like um, our value engineering study. So uh, basically, we do not consider these as a outcome when we consider our value engineering process. So these are not considered when we consider an outcome of a successful implementation. So yeah, coming on to the next question. If you have any doubt, please stop me in between and we can discuss that question further. So which of the following team has the greatest impact on the cost saving during the life cycle of a product development process? So any guesses will be also fine. We can discuss further. And why do you think it will be designed? Can you give me any explanation for the same? A lot of changes can be done. Okay, one explanation, another explanation, please. Yes. So the way of the engineering and manufacturing is whatever we basically is being decided at the design state itself, as it will be freezed. So they shape the, as he said, 80% of the product development cycle. Then coming on to the next one, this is just a implementation based question. So what do you think is a basic function of an overhead projector? Any other answers? Yes. So the basic difference between a bulb or a lamp versus projector is mm, mm, just to remind the basic difference here. Then coming on to the next question, which of the following parameter is are considered during the evaluation phase of a divan? So divan is the large size, king size bed that we generally use at our home. So all of the above. Okay. Can you give me any explanation of the same? Okay. Yeah. And as it's also seen as a long-term investment, so we would also see durability and the rigidity constraint too. Yeah. Okay, so coming on to the quality function deployment part, is also known as the house of the quality because of the circular structure. I should have showed this figure later, but yeah. Is it true or false? So yes, as we can see, it resembles, yeah, it's kind of self-explanatory. So it resembles a house rather than a circular loop or any other circular structure. So QFT is a systematic approach of translating customer requirements into appropriate requirements at each stage from so R&D to engineering stages, engineering to manufacturing stages, R&D to distribution and sales stages, or none of the options above are true. Okay, can you also give me an explanation for the same? Mm, yes. So, yep, accepted explanations. So, like to get to know their actual requirements after like designing the product, also we kind of take feedbacks and continue improvising the products till we meet the exact specifications. So it might happen that we would have thought of some other constraints, but in actual or real practical scenario, the constraints are different from what we actually designed for. So yeah. Then coming on, which of the following is related to competitive technical assessment of quality function deployment? Competitive technical assessment. Sorry. Yeah, please give if you have any guesses. So I feel the answer is okay. Okay. Given the technical term is there in the assessment. But yeah, okay. So let me tell you the answer. Yeah, please. Yes. Yes, so we actually look at how well the company fares against its competitors in terms of performance. So, an assessment typically involves creating a list of competitors, creating a profile for each competitor that includes information such as what are the type of products my competitors are selling in, and the services they are selling into the market, their market share as a total, what are their strategies, and how we can basically find their strengths and weaknesses to exploit and um, get an fair advantage over them. Then coming on to the next question, which of the following is are the phases of QFD? Um, yes. So in the first product planning, we basically translate the customer needs into the design requirements. And in the process planning stage, we decide on the design, manufacturing, and assembly process that best addresses the requirements. And in the production planning part, we kind of try to process control methods that are there, and along with the production and the inspection of the processes going on. So then coming on to the next question, that is computer aided design mainly comprises of. Yeah. So basically, this is to just showcase the power of computer-aided designs. So we have computer-generated graphic concepts. We have triangulated mesh and structure. We do have geometric modeling of the objects. We have design tools such as we can perform stress strain analysis. We can give some constraints and heuristics to actually model the complete process. So yes, one of the quite infamous tool that we use, that is finite element analysis, um, which comes under which category? Uh, Come again, please. One said engineering analysis and one said geometric modeling, right? Okay, so the correct answer is engineering analysis. Yes, FEA is basically a computerized method for predicting how a product reacts to the real world forces, vibration, heat, fluid flow, and other physical effects. So, a physics-based modeling, if I can say. Then coming on to the next question, which is which of the following type of ergonomics deal with the mental processes and capacity of human when at work? Yes. Cognitive ergonomics. So it deals with the mental processes such as perception, memory, thinking, and the mobility and the way they are affected by the interaction with the remains of the observed system. So to keep all these things, we design our system to keep while considering all these things um, parallelly. So coming on to the, I feel the last question of our today's tutorial. As per the design for assembly guidelines, the reorientation of components during assembly must be kept as minimum. Can you also give me any explanation why we should keep the reorientation minimum? Correct. Yeah, actually both the explanations are correct. This is to avoid the handling and the reorientation issues, and it also provides reduction in overall assembly time. So that was all for today's tutorial session, and a very happy Independence Day to all of you. So if you have any questions, please let me know. We can discuss the same. You too.